What if I told you that the fish oil supplement you took this morning, the one your doctor practically begged you to take for your heart, might actually be accelerating your path to a heart attack?
Yeah, it sounds completely backwards, doesn't it?
It really does. Welcome to the deep dive. Today we are tearing into chapter 12 of Dr. Daniel Wallerstorfer's book, Unlock Your Genes for Precision Health, and exposing a massive biological irony in standard health
Right,
advice.
because we are going to map out the invisible microscopic logistics happening inside your veins right now.
Exactly. And look at how your DNA dictates absolutely everything about the fats in your blood.
Which is so important because, well, the standard operating procedure for health has always relied on this idea of a universal rule book.
Like one size fits all.
Exactly.
Yeah.
The medical community really wants to believe that if we all just follow the exact same recipe, we will all get the exact same healthy result. But the moment you introduce genetic variation into the equation, that universal rule book just goes completely out the window. Like, what protects your neighbor's heart could actively damage yours.
I mean, that is a terrifying concept, especially when you apply it to something as universally feared as cholesterol.
Oh, absolutely.
To ground this in reality, the source starts us off with an incredibly striking real-world case. It's the story of a man named Bill Lindsman.
Yeah, Bill's story is rough.
It really is. Bill suffered his first heart attack before he was even 40 years old, 39 to be exact.
Which sounds impossibly young.
Right, but for him, it was almost expected. He had experienced severe heart problems from an early age, and this was like a dark shadow hanging over his family history. His father had also been treated for massive premature heart issues.
And, the medical interventions for Bill really paint a grim picture of what happens when your biological systems are fundamentally broken.
Yeah, what were the timeline details there?
Well, 10 years after that first heart attack, his vessels were so compromised, he required a bypass operation.
Wow.
And he made it another 14 years before suffering a second heart attack at age 63, which then led to the implantation of a stent.
Just nonstop cardiovascular events.
Exactly. He always knew his cholesterol was astronomically high, but he spent decades unaware that he was actually battling a specific genetic disease. It's called familial hypercholesterolemia.
Familial hypercholesterolemia. So a massive, genetically driven misregulation of blood fats.
Precisely.
Now, our listeners definitely know the high school biology basics here. We know cholesterol gets a bad rap, even though the body contains about 35 grams of it, making up 30% of our cell membranes.
Right. It's not inherently evil.
No, it's vital for vitamin D, hormones, and digestive bile. The liver makes about 1 gram a day, and the average European eats another 300 milligrams daily.
Yeah, and we also know the delivery system, right? So LDL proteins are the couriers dropping fat off at the cells.
And HDL proteins are the garbage trucks hauling the excess back to the liver.
Exactly. And that background is crucial because it highlights the actual mechanical problem the body has to solve. Fats just do not mix with water.
Like oil and vinegar.
Right. The book actually uses this very visceral analogy. Think about a bowl of hot soup.
Okay, I'm picturing it.
As it sits there, the fat pools together, right?
Yeah.
Forming these thick, floating droplets on the surface.
Oh, yeah, those greasy little pools.
Well, human blood is a water-based system. If the body just dumped raw cholesterol into your bloodstream, you would have those exact same fatty droplets congealing in your veins.
Ugh, what a visual.
So the LDL and HDL transport proteins prevent that by safely encapsulating the fat.
So as long as the delivery drivers and the garbage trucks are doing their jobs, the streets are clean.
That's the idea.
But arteriosclerosis, the calcification of the arteries, happens when those garbage trucks basically go on strike.
Yes. The LDL couriers keep dropping off packages, the HDL trucks aren't picking up the trash, and the excess cholesterol starts depositing onto the walls of the blood vessels.
But here's the mechanism I really want to understand. Why did Bill's garbage trucks go on strike in the first place? Like, if his body was producing the transport proteins, where did the system break down?
So the breakdown happened at the cellular drop-off point. And this is governed by something called the LDLR gene.
LDLR, okay.
This gene's entire job is to create a very specific tool known as the LDL receptor. Picture a microscopic gripping arm, basically, anchored to the surface of your liver cells.
Okay, a gripping arm.
Right. As the blood rushes past the liver, these gripping arms reach out, latch onto the passing LDL cholesterol particles, and literally pull them inside the cell to be safely stored and processed.
So it is the primary mechanical filter for clearing bad cholesterol out of the blood.
Exactly.
So if I'm visualizing this correctly, Bill's genetic glitch meant those gripping arms were physically deformed.
Yes, exactly.
Because the source notes that one of his two LDLR genes was defective, that means half of the gripping arms on his liver cells were built perfectly and were filtering the blood,
Right, doing their job.
but the other half, produced by the mutated gene, were essentially mangled. They just couldn't grab the passing cholesterol packages.
And that 50% reduction in functioning gripping arms was all it took to completely capsize the delicate balance between HDL and LDL.
Wow, just a 50% drop.
Yeah. Over decades, the trash collection service was completely overwhelmed. The uncollected fat deposited into his artery walls, narrowed the vessels, and ultimately suffocated the blood supply to his heart.
The statistics tied to this specific defect are chilling, honestly. In Europe alone, 1 in 250 people carry this exact LDLR defect.
It's way more common than people think.
And 40% of those people face serious cardiovascular problems by the time they hit age 50.
Yeah. And it gets worse. If someone is unfortunate enough to inherit a defective LDLR gene from both parents, meaning almost none of their gripping arms work, the arteriosclerosis typically starts developing in childhood.
In childhood, that is just incredibly unfair.
It is. But the gripping arms are actually only one side of the genetic equation here. The source introduces a counterpart gene called APOB.
Okay, APOB, how does that fit in?
You can think of the APOB gene as the shipping label on the LDL package. It builds the specific molecular signature on the cholesterol particle that the liver's gripping arm is actually designed to recognize.
Ah, okay. So the arm could be perfectly shaped, but if the APOB gene is defective, the package basically has a barcode the scanner can't read.
Exactly. The gripping arm reaches out, bumps into the LDL, but just doesn't recognize it as cholesterol, so it lets the dangerous fat float right on by.
The clinical result is identical then, catastrophically elevated bad cholesterol.
Spot on. About 1 in 600 people carry this APOB defect.
Wow.
And when you combine defects in the LDLR gene, the APOB gene, and a third regulatory gene called PCSK9, you account for about 40% of all familial cholesterol disorders.
I have to pause here and challenge this on behalf of anyone listening who is religious about their health tracking.
Sure, go for it.
We are so heavily conditioned to believe that lifestyle conquers all, right? If someone discovers they have this defective LDLR or APOB gene, can they just exercise their way out of it? Like, what if they eat a perfectly clean, plant-based diet, never smoke a single cigarette, and run ultramarathons every weekend? Doesn't the body adapt?
I wish I could say yes. But the brutal biological reality is that for these rare monogenetic defects, optimal diet and rigorous exercise barely move the needle.
Barely move it.
Barely. Because the physical machinery required to clear the cholesterol is fundamentally broken or just entirely missing from the factory floor.
Right. You cannot outrun a missing gripping arm.
Exactly.
Yeah.
For these individuals, lifelong medication is mandatory. It is the only scientifically viable way to manage the risk.
That is a heavy realization. Extreme genetic defects require extreme medical intervention. But that brings up an entirely different mystery. Most people walking around don't have familial hypercholesterolemia. Yet, we see millions of people whose cholesterol slowly, stubbornly creeps up as they hit their 40s and 50s.
So true.
If they don't have broken gripping arms, what is failing in their systems?
Well, shifting from rare monogenetic conditions to common genetic variants reveals that almost all of us carry a few critical glitches in our lipid management software.
Okay, glitches in the software, not the hardware.
Right, these aren't broken gripping arms, but rather faulty regulatory systems that govern the whole process.
The source material highlights the SREBF2 gene here. It describes it as a genetic traffic light.
Yes, great analogy. Its job is to keep all the other cholesterol-regulating genes synchronized and firing in the correct order.
But a staggering 60% of the population has at least one defective SREBF2 gene.
60%.
That's wild. If your traffic light is broken, the intersection turns into chaos, and you end up with increased LDL and a significantly higher risk of a heart attack.
Exactly. And then think about the CETP gene as well. It acts as the logistics manager, responsible for loading and reallocating blood lipids between the different transport mechanisms.
Let me guess, a lot of people have a defect there too.
Again, about 60% of people have a defect here.
Wow.
When the logistics manager drops the ball, your good HDL cholesterol levels plummet, leaving you without enough garbage trucks to clean the streets.
And we also have APOE5. 29% of people have a defect there, which indirectly impairs those LDLR gripping arms we just talked about, and also worsens HDL.
Right.
But the source points out that APOE5 also heavily impacts triglycerides.
Yes, triglycerides represent a totally different category of dietary fat. While cholesterol is primarily for cellular structure, triglycerides are used mainly as energy reserves stored in our fatty tissue.
So we need them.
They are absolutely necessary for survival, yes. But an excess accumulation in the blood causes severe secondary issues like diabetes or acute inflammation of the pancreas.
And both the APOE5 gene and the APOE gene dictate how effectively your body clears those triglycerides.
Exactly.
The APOE gene really caught my attention because the author of the book, Dr. Wallerstorfer, openly shares that he carries the defective variant along with 25% of the population.
Yeah, he's very open about it. It specializes in the docking site of those gripping arms.
Mm-hmm.
If APOE is effective, the LDL isn't extracted properly.
But looking at the data tables in Chapter 12, I mean, it's honestly overwhelming. I'm staring at this massive wall of gene acronyms. SREBF2, CETP, APO5, APOE, CDH13, CHDS8, the list goes on and on.
It is a lot of letters and numbers.
It feels like dodging bullets in a matrix where every single person gets hit. If we all have these hidden genetic traps waiting to spring, what is the actual workaround?
Well, to find the workaround, we have to examine the most famous, universally prescribed cholesterol treatment on the planet.
There we go.
The absolute golden child of the supplement aisle, omega-3 fish oil.
The fish oil paradox.
Yes. Unpacking the genetic mechanism behind fish oil exposes one of the largest controversies in modern nutritional science.
If you asked any doctor or nutritionist, the standard playbook is to take polyunsaturated fatty acids, PUFAs, usually in the form of omega-3 fish oil capsules.
It's recommended everywhere.
The pitch is always the same. These unsaturated fats lower your bad LDL cholesterol, reinforce your cell membranes, and aggressively reduce inflammation.
And to be fair, the medical community didn't invent those benefits out of thin air.
Right.
Omega-3s possess incredible anti-inflammatory properties. They are highly effective at calming down an overactive immune system, making them a staple treatment for inflammatory diseases like rheumatoid arthritis.
That makes sense.
They're also undeniably necessary for the healthy brain development of fetuses.
Though the text does add a fascinating caveat there. A meta-study showed that women taking fish oil during pregnancy had babies who were 3.5 IQ points smarter.
Very specific number.
Yeah, but the catch is that modern nutrition in developed countries usually provides enough baseline omega-3. Taking extra supplements on top of a normal diet doesn't actually boost the baby's IQ any further. You just can't supercharge it.
Right, there's a ceiling to the benefit. But the real plot twist has nothing to do with brain development or joint pain. When it comes to managing cholesterol, everything hinges on a gene called APOA1.
APOA1.
You can think of the APOA1 gene as the key that turns the ignition on the cellular garbage trucks.
Okay.
It enables the molecular waste disposal system to actually transport and get rid of the excess fat.
And based on everything we've learned so far, I am going to guess a huge chunk of the population is walking around with a broken key.
34% of the population, to be precise. Over a third of people have at least one defective APOA1 gene.
A third of the population.
Yeah. Because their waste disposal system struggles to turn on, they face a 1.47 to 1.9-fold increased risk of coronary heart disease.
That's significant.
It is. But here's the thing. For this specific 34%, taking omega-3 fish oil is nothing short of a miracle.
Really?
Yeah, the supplement beautifully counteracts their genetic deficiency, and their good HDL cholesterol levels improve significantly.
Oh, but wait, if 34% of people have the defect, that leaves 66% of the population with perfectly functional APOA1 genes.
You see where this is going?
What happens when that two-thirds majority takes fish oil to protect their heart?
Absolutely nothing positive.
Oh, nothing.
For the 66% of people with two functional APOA1 genes, taking additional omega-3 fish oil has zero beneficial effect on their cholesterol.
You're kidding.
And the true biological irony is that for a significant portion of this majority, pumping extra omega-3s into a system that is already functioning normally actually makes their lipid values worse.
Let me make sure I'm hearing this correctly. The Universal Rulebook tells everyone across the board to take fish oil for heart health.
Correct.
But for 66% of the population, it either acts as an expensive placebo or it actively sabotages their cholesterol profile.
The genetic data is unequivocal on this. Dr. Wallerstorfer actually used himself as a guinea pig to prove the point.
Oh, I love a good self-experiment.
As we established, he struggles with bad cholesterol due to his defective APOE gene. However, his genetic test showed he has two perfectly functional APOA1 genes.
So he falls squarely into that 66% majority.
Exactly.
So he knew fish oil shouldn't work for him.
He knew the theory, yes, but he ran a strict self-experiment anyway. He took high daily doses of omega-3 fatty acids for 4 straight weeks just to see how his body would respond. At the end of the 4-week protocol, his blood tests confirmed the genetic prediction. His cholesterol levels had officially worsened.
Wow, that completely shatters the illusion of universal health advice.
Completely.
If someone doesn't know their genetic profile, they could be spending a fortune on supplements every month, genuinely believing they're protecting their heart when they're literally throwing gasoline on a fire.
It perfectly illustrates why the concept of precision health is dismantling the whole one-size-fits-all approach.
Yeah, it really does.
If you have two functioning APOA1 genes
Yeah.
and your cholesterol is already out of control due to a different genetic glitch, you should actively avoid taking additional omega-3 fatty acids for lipid management. You are just overloading the system.
Okay, let's theorize here. If fish oil is genetically counterproductive for 66% of people, what do?
Good question.
If the garbage trucks are broken and fish oil just adds more trash to the pile, what is the actual biological hack to lower their bad cholesterol? Especially for someone who might be vegetarian and wants to avoid animal-based supplements anyway.
Well, the solution lies in the plant kingdom, relying on a brilliant mechanism involving compounds called phytosterols.
Phytosols. The source describes these as essentially plant cholesterol, right?
Exactly. They are the structural substance found in the cell membranes of plants, serving the same purpose that cholesterol serves in animal cells.
Okay, and you can find high concentrations of it in linseed oil, hemp oil, rapeseed oil, chia oil, and walnut oil.
Right.
It's also abundant in solid foods like walnuts, almonds, pumpkin seeds, spinach, avocados, Brussels sprouts, beans, and soy.
Yep. All great sources.
Yeah.
And the beauty of phytosterols is how they exploit a blind spot in human biology.
A blind spot.
Yeah, the mechanism that lowers your blood cholesterol happens entirely in your intestine, long before the fat ever reaches your bloodstream.
Oh, interesting.
From the perspective of your intestinal receptors, phytosterols look so structurally identical to animal cholesterol that the human body literally cannot tell the difference between the two.
It's a biological decoy.
That is exactly what it is.
Think of your intestine as a busy waiting room with a strictly limited number of seats. If you consume a meal rich in these plant phytosterols, they rush in and occupy every single seat in the waiting room.
And by the time the bad animal cholesterol arrives from your diet.
There is simply no room left.
Exactly.
The intestine happily absorbs the harmless plant phytosterols, leaving no time or physical space to absorb the dangerous dietary fats.
Right. Because those bad fats can't get a seat, they bypass the bloodstream entirely and are harmlessly excreted down the toilet.
That is incredibly elegant.
The mechanical displacement is highly effective because a significant portion of the bad dietary fats are never absorbed into your bloodstream in the first place. Your overall LDL blood levels organically drop.
So, for the vast majority of people whose genetics render fish oil useless or actively harmful, leaning heavily into phytosterol-rich foods provides a natural workaround.
Yes, it bypasses their internal genetic bottlenecks by stopping the bad fat right at the door.
So, as we pull all these threads together, the implication for your own health journey is profound. Whether you are prone to dangerous blood lipids and whether a daily supplement like omega-3 will heal your heart or quietly harm it is entirely pre-written in your DNA.
It's all there on the code.
If you have stubborn cholesterol levels that refuse to budge no matter how many miles you run, or if multiple people in your family have a history of heart issues, flying blind and guessing with supplements isn't just inefficient, it's dangerous.
Truly.
Getting a genetic test for predispositions, like checking the status of those LDLR gripping arms or the APOA1 waste disposal genes, provides the actual blueprint for what your specific body requires.
The shift to precision health changes the entire power dynamic of aging. You stop fighting against an invisible enemy and start working with the unique biological machinery you were actually born with.
I love that. I want to leave you with a final thought to mull over as you go about your day.
All right.
The next time someone insists that a specific superfood, diet trend, or supplement is universally healthy, or hands you the standard rulebook for a long life, remember that your DNA always has the final say. The very compound that acts as life-saving medicine for one person's biology might literally be the poison in another's. We don't need a universal rulebook anymore. We just need to learn how to read our own.